So last time we left our heroes, we were talking about dynamic programming, not dynamic programming, inheritance, and we wanted to show you like what could be the use of this. So what I did is over here I made a vector of unique pointers to shapes, right? Where our shapes could be either rectangles or circles. That's all that we have for shapes right now. And what I did is I went through and for all the even positions, I made circles there, and they had some random radius between 1 and 20. Then I made some rectangles. They had some random like width between 1 and 20 and some random height between 1 and 10. Right? And notice this vector is able to hold, pointers to shapes. That's how I'm able to get in both circles and rectangles, right? I couldn't just say, well, you can say I want a vector of rectangles, but then you can't put circles in there. Or you can say I want a vector of circles, but you can't put rectangles in there. The only way to get a vector of just having a vector that can hold both of them is by using the inheritance. So then what I did is I made some variable area. It's initialized to 0. And then I go through each one of my shapes that I have, right? And when I'm inside here, I don't know what shape I'm in, what shape this current shape is. I just know it's a shape because all I have are shape pointers. I have no more detail. So you skip lines 26 and through 32 for a moment, right? We get the area of the shape by calling shape get area. But if it's a circle, it'll calculate the area of the circle correctly. If it's a rectangle, it'll calculate the area of a rectangle correctly. But it'll do that different calculation, and then we add a result to the area. Right? If I wanted to add in new shapes like triangles or trapezoids or whatever else we happen to have, and I wanted to be able to get their areas, this loop wouldn't have to change, right? Just go through each shape, call its get area. I don't have to do anything different. If we want to be able to figure out exactly what type of shape that we have, which may or may not be necessary for the problem that we're on, we can attempt to dynamic cast that pointer to the child type. So I'm trying to cast my parent pointer of type shape to a circle pointer. And then I attempt to, again, cast that parent pointer type of shape to a rectangle pointer. And if the cast succeeds, we'll have a pointer that's valid. If the cast fails because that type that we're pointing to really is not that, then we are going to get a null pointer. So if the cast fails, this expression won't hold true. So if circle pointer is not null, it's a circle. If the rectangle pointer is not null, it's a rectangle. Any questions here? And so like now if I go ahead and I build this, right, you can see that it's a circle, it's a rectangle, it's a circle. It goes circle, rectangle, circle, rectangle, circle, rectangle, just like we put them in there. What do you think would happen if instead of using dynamic cast here, I had made a mistake and I had said static cast instead? What do you think would happen? Do you think it would fail to compile? Do you think it would cause some error at runtime? Right? Well, so here, right, static cast means I'm 100% certain that that thing really is supposed to be that type, right? And so it's not going to do any checking for me. And so these pointers, since they're actually pointing to something, none of them will ever be null. And so now if I run it, it's going to say everybody's a circle and everybody's a rectangle. Because they're both not going to be null. Right? You notice it says that they're both circles and rectangles for each shape because we accidentally did static cast, right? We assume, and the compiler did not do any checking for us because we said we are 100% certain that this type of the thing that we're pointing to really is this. And so what would actually cause problems and give me some like undefined behavior is if I tried to attempt to access the child member methods that were particular for a circle only or for a rectangle only. Right? Like if I tried to access like the the circle's like radius field, it would, seems would be fine. Like the current shape is a circle, right? With radius. And now we put in, I can now do circle pointer, arrow, get radius, right? Because that's perfectly fine because all circles have a radius, right? Or the current shape is a rectangle with width, rect pointer, arrow, get width, and height, or I guess, and length. Put a space there, put a space there. And again, this is, again, all still like 100% syntactically legal because I have child pointers. Just 1 second. But now, again, because I still have these static casts there, like I don't know what's going to happen, right? So it's a circle with radius 14, but it's also a rectangle of 28 and 14, right? But then, like, it's a circle of 3 with width 4 and length 3. It's like, doesn't quite make sense for what's supposed to be going on, right? Because I'm getting values for things, but the behavior here is very undefined as to what should be happening. Probably what's likely happening is I'm calling functions to like getting one of them's like diameter instead by accident. But I'm not sure what's actually going to be happening. But if I switch back to dynamic cast, right, and then these might be some like really hard bugs to track down if you actually hadn't made that mistake, because everything seems to be working. Pointers are all valid. You're getting values back, but things aren't what they're supposed to be. The first one really is a circle with radius 14. The next one is a rectangle with width 4 and length 3. We had static cast. What did it say again? Oh, whoops. So the first one's supposed to be a circle. It had radius 14, but we also said it was a rectangle with width 28 and length 14. Well, what's twice, right? The radius, the diameter, right? And so it's probably calling, instead of calling like the, where it's trying to call like the get width function, it's probably actually calling the get diameter function. And so things happen to map to the correct locations in memory. We didn't get any segmentation faults, but we're not getting the values back that we should be expecting. So back to dynamic cast. You had a question? So the question is, why can't I have a vector of shapes? Anybody want to give a shot at why I can't have a vector of shapes? That's one of the things is like terms of sizes and terms of how these objects are laid out, they might not be the same, right? Because when you're saying I want a vector of shape, right? You're only going to make space for a shape, right? But if there's more stuff, right? Like if the childs have more things in them, they won't have space be made for them there, right? Any other reason why we couldn't have a vector of shape? Yeah, so the question is, why do we have to have a vector of shape pointer and not just a vector of shape? Yeah, the vectors, they can point to different types, absolutely, right? Be there a circle or a rectangle, but there's some other reason besides the sizing issue that we talked about earlier. Yeah, that was the same answer that's down here. Like the size of a rectangle, the size of a circle is probably larger than the size of the parent shape, right? So your child's are your parent plus more stuff, right? And so by just making a vector of shape, you wouldn't have enough space to fit them all. But there's another reason here why we couldn't just have a vector of shape. Shape is a purely virtual class, right? Because at least one of our functions here is virtual, right? It has no implementation. We cannot have an instance of this class, right? So if you have at least one virtual member, you are not allowed to create any implementations of those classes, only pointers or references to those classes. So that would be the other reason why the compiler wouldn't allow us to do a vector of shape. Do you guys have any other questions? Okay. So here's another very similar example to the one that we just did. So, right, let's say we have a zoo. A zoo is made up of animals, right? But there are different types of animals, right? And so over here is our zoo, and it's still building, right? So we have our zoo, and again, we have a vector of unique pointers to animals. And some of the methods that we have here are like, we want to get all the cats that are in our zoo. We want to be able to get all the dogs that are in our zoo. I don't know why we have cats and dogs in our zoo. That's apparently what we have. And then we also have the ability for all of the animals inside the zoo to make their appropriate noise. So we're going to go through all of them and say, you know, make your noise, whatever it happens to be. So over here in animal, right, all of our animals happen to have a name, right? And we also provided a member to get name. Makes sense? And notice that we also have the ability to make a noise, but because we don't know at the parent level what it makes sense for an animal's noise to be just in the generic case, we cannot provide really any implementation details here for our children to fall back on, right? So we make it purely virtual here, right? That's when you decide to make a method purely virtual. It's when you don't, you make a member virtual when you have, it doesn't make sense to provide any generic code for your children to run. Something that makes sense in situations for at least most of your children, if not all of your children. And then over here we have a cat. It has a name and the ability to make the noise. And the cat's constructor, we call our parent's constructor to initialize our parent portions, just our name. And then for when we make a noise, it just says the cat says meow, whatever its name is. Right? And then the dog is, you know, pretty much identical. Again, he also has a name, and his name is initialized via a call to his parent's constructor. And then the dog just says wolf. So now over here in our main, or zoo.h, our make noise, right? We just go through all of them and then say, hey, each animal, make your noise, whatever it's supposed to be. For adding an animal to our zoo, we just take in an animal pointer. Actually, it's a right-hand side reference because we have unique pointers. Probably a better way of doing this instead of using the unique pointers out here would be to just have accepted a animal reference and then do a pushback after we do a make unique, which we'll change to that in a second. This should be more like this. Because we shouldn't be working with pointers here. Oh, wait, maybe. Actually, I take that back. We'll leave that for right now because the issue that we have here in trying to use like pushback or in placeback with just an animal. Oh, no, wait. Pointer. Oh, no. We're going to leave it right now because I'm getting myself confused. So for getting the cats right, we just go through all of our cats. We attempt to dynamic cast it to a cat pointer. If it succeeds, we add it to our list of cats. Right? And then the same thing for a dog. We go through our list of animals. If it's a dog, right, we push it back. Yeah. What does .get do? Oh, so remember that the vector that we have is of unique pointers. So .get gives you the pointer that's being stored inside the unique pointer. And then over here in main, right, we make a cat, and we make a dog, and we make another dog, and we make another cat, and we make another cat, right? And we keep putting them into our zoo, and then we say for them to make their noises. So we should say here something like, Cato says meow, Doggo says wolf, Airbud says wolf, Blackie says meow, Meowser says meow. And we can see that each of the animals in our zoo is making the appropriate noise. Right? If we wanted just to get the cats, we could have a std : vector of cat pointer called cats, and that would be equal to the zoo dot get cats. And then we could, say like, for const auto reference cat in cats. Cat dot make noise, or arrow make noise. And now we should see that after we go through each one of our cats and have them print out, we should also see that each of our cats get an additional opportunity to make a noise. You guys have any questions so far? So thinking back to this guy over here, he's a right-hand side reference. That's what the double ampersand means, and it's going to be used in terms of a move. One thing that would probably make a lot of sense is I want an animal reference or something. But the problem then is that if you try to go put this person into the zoo, is you don't know whether they are a cat or a dog, so you don't know how to make space for them correctly to insert them. If you just took in some animal reference, you could, make a new unique pointer to an animal and have them point to the address of that animal. But then again, you're not really taking. Yes, you would technically be taking ownership over that thing, but since the space wasn't dynamically allocated, now you might have issues. So this seemed, I guess, to be actually the best way of getting your animals into the zoo. The other method that you could have is inside this function, you'd have to check to see whether the animal you were given was a cat or a dog or a whatever it is, right? And then you could go make a unique whatever, cat or dog, and then push them back into the zoos, the list of animals that you have. That would work, but then it looks kind of ugly because you're now relying on the types to make sure that you're storing the right thing. But I don't know right now any other way around that if you wanted to accept an animal reference. Any questions before we move on? So a lot of you guys had questions yesterday about multiple inheritance. Somebody had a question about the diamond thing, you have a parent and then we have two people that split off and then it goes in. Turns out I actually had an example of that, which we're going to go through now. So over here we have some classes. Our first class that we have is a person, and a person has a name and the ability to get a name, right? You might decide if you're going a little bit more involved that people have more things like an age and a height and a weight and a eye color and a hair color and blah, 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 blah. But we're not going to get into that much detail here. We also have workers. Well, what are workers? Workers are people, right? I guess unless they're machines. But we're saying all of our workers here are people. They also, again, have a name because they inherited that from their person. and they also have the ability to do some work based on whatever their job happens to be, right? But different workers do different work. We also happen to have a student. A student just right now is more or less the same thing as a person, but we have the ability to add more things, like maybe a student has like a list of courses that they take and a school that they attend, and they might have an instructor or something. Yeah. Oh, I think these protecteds just accidentally got generated from other things because they were both empty. So we also have instructors, right? An instructor has a subject that they teach, right? And they also have a list of students that they teach that subject to. We also have a researcher, and a researcher does research in some field, right? And for their do work things, they're not very interesting, right? You just say whatever your name is, did some research in that field just to see that it's happening. And then your instructors, when they do work, they teach their students. So whatever their name is teaches this subject to blah, 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 blah. Right, and then we go through our students and we print their names out. Well, if we think about professors, what are professors? They are people, they're workers, right? And they're also, what else? They're researchers and they're instructors, right? So, hey, here's our professor. He inherits from both researcher and instructor. He does both the things. And so now this might start to create a little bit of confusion. Because if we think about researchers, researchers have a name. And your instructor also has a name. And now your professor has two names. They have their researcher name and they have their instructor name, which is kind of weird. But because we are inheriting from these classes, we get everything from the parent. So now we have two names, researcher name and our instructor name, right? When ideally we probably would only want one name, but that's not how this works out. And that's why generally when you do multiple inheritance, it's inheriting from multiple interfaces, which again, if we're using the Java terminology, like an interface is a class that just has methods, doesn't have any members, right? We also inherit both our researchers and our instructors do work. So now we also have two do work methods that we've inherited, our instructors and our researchers portions. So we have two of them now. And for our constructor, we have a name, a field, a subject, and we have our students. So if we pop back over here, right, we can see that we made our researcher name be whatever our name is, and then our instructor name is always just going to be Jones for whatever reason, just so that you can see things happening. So if I was down here and I just said get name is ambiguous because do I want my instructor name or do I want my researcher name, right? I don't know. So if you want to clarify which one you want, you have to preface it with the name of the class. So if I wanted my researcher name, I could do researcher name, : get name. If I wanted my professor name, I could say professor name, : get name, and that would call that appropriate parent's get name. And so for doing the professor's work, we do our researcher work, and then we do our instructor work. Does that make sense? Any questions so far about this multiple inheritance and this weird fact that we have both? Yeah. So the question is, can I provide a function with a different name to override one of my parents' members? No. Like the signatures have to be identical for when you do the override, which the signature includes the name. If you wanted to and you wanted that behavior though, you could have like your do work call the research do work, but it's a bit ambiguous. The other thing is which is kind of interesting, and I'm not sure how to do it if it's possible, is because we've inherited like do work from our professor, and we've inherited do work from our researcher, and we've inherited do work from our instructor, right? And I don't know if it's possible to only override one of them. So like, how could I override my researchers do work with something and override my professors do work with something? I don't know actually how to state that, or if it's possible. I'd have to do some Googling, because it's just a thought that occurred to me right now, because I've never tried to do that before. But I imagine that it is possible. I just don't know how at the moment. The other thing is over here in main. So you can see that I make some students, Bob, Joe, Sally, Lauren. We have our professor, Mike. He teaches, he's a researcher in chemistry, and he teaches biochem to these students. So if I say professor.dowork, he's going to do both parts of his work, his researcher work and his researcher work and his instructor work. But you might ask, well, what happens if I only wanted this professor to do their researcher work? Well, you'd have to do, well, any guesses what you would do? So like prof.research, oh my gosh, I can spell. Did I spell it wrong? Searcher. There we go. And this is how I could say that I want to particularly just do the professor's, the researcher work of the professor, not do whatever they override the method to be. So you can specify it there. We also had a good question in office hours, not office hours, but in discussion on Monday, that would it be possible, right, over here, right, we've inherited a name. Could we have another member called name? Apparently, yeah, it's fine. Right? But now I have, so now I have like the professor's, I have my researcher name, I have my instructor name, and I have my new integer called name. So like, yeah, you probably could do like professor : or professor, no, let's try it out. So prof.name is fine. The one thing I want to check is a name is protected here, so we couldn't access it, right? Now, the more curious question would be, it's now public. And now here, I would expect a number to be printed out, right? And so random garbage number comes out because it didn't initialize it, right? But if I wanted like the name, I'd probably have to like do like prof.person : name. And now, oops. Oh, because he inherited from both his like teacher or instructor. So if I wanted to get my instructor name, which I think we always made Jones, you can see like Jones just prints out there. That's how you can disambiguate between like which one that you want. We go back here, and again, we make this protected. And now if you're back here inside professor, and again, if we just said name, name here probably means some number. Oh, it's not going to compile because not public anymore. right? And you can see like some random number got printed out instead. So multiple inheritance, it does exist, it does have value, but in general, the most common time when you're going to do multiple inheritance is again when you're inheriting from multiple interfaces, right? Again, we made the example on Monday that you might have an interface called comparable, where you have to implement a not equals and an equals equals operator, right? Then you might also want something that's orderable. It has to implement the less than operator. So you might have something that inherits from both orderable and comparable, right? And that might make sense to have something that does that, where it has to implement all of those things. Any questions? I guess the other example of with that is you might make your, if some like orderable inherits from comparable, right? Because if you're orderable, you have to be comparable. Make that happen. Any questions before we continue on? Okay. So what I kind of want to do now is I don't think I have any more interesting examples, but I want to do something. Oh, this one might be good to look at. After we look at this, which is this is like the protection level stuff and things like how if you try to upgrade the protection, what's going to happen, is I'd like to go back to the Pokemon game that we're working on, and I would like to add in some AI so that we can have players play against players and players play against the AI, or AIs fight AIs for whatever we want to do, right? And that's going to involve some inheritance, because now we might have like our Pokemon is our base class, right? But then we might have like a player Pokemon and an AI Pokemon. Or maybe now we have two players, depending on how we decide to structure it. And we might have an AI player and a human player. They both have Pokemon, right, to use to battle, but how we get moves from them would be different. So over here is our base class. It has a public member X, a protected member Y, and a private member Z. And then it has two methods that are public, base class, and print base. Is our constructor to initialize X, Y, and Z, and then print base just prints out the values. So we'll start with the most common form of inheritance first, and then we'll work our way back down. So let's say that we inherited publicly from inside of our class, right? This means that basically the protection levels don't change at all, right? Because we're saying everything has to be at least as high as public, and since everything is at least public, right, that's like the least stringent protection level, nothing changes. So X becomes public inside of ourselves, Y becomes protected because it was protected before, and Z becomes private. So now inside of our functions, to initialize, we just call our parent constructor to do the initialization. And I can print out X, I can print out Y here, but I can't print out Z because Z is private inside my parent, and I no longer have access to that. Right? So you can't get direct access to any of your parents' private members or private members or private methods. Those are off limits to you. Does that make sense? Okay. Yeah. So the question here is this function that you're trying to make, right? Was it virtual in your parent or not? Well, yeah, I guess you can't really override private members. So that makes our private methods, so that makes sense. So what would happen is you would create, that method would then become overloaded, right? And so when you called whatever that name of that function was that happened to have the same signature, you'd be calling the child's implementation of it. right? Now, the real difference of like what's going to happen here is if you have a parent pointer, right, that now points to the child, right, and attempt to evoke that function through the parent pointer, it's going to attempt to call the private parent member, which will now not compile, right? So if you have an instance of the child class, right, and assuming that method that you made was now public, right, and you do my child dot this new public method that just happens to have the exact same signature, great. If it gets called, it gets run, right? But if you have a parent pointer, you can only access the parent parts. And since it's not overridden, right, we can't access that member.
And you try to call private parent child class. All that.
No, if it was a parent pointer, you still couldn't call that method because it's still private, right? You just unless you were inside the class itself.
Right.
If you were inside the parent class, you could call that private member, but outside the parent class, you could not access it. So let's say that instead of inheriting publicly from this class, you decided to inherit at a protected level. What level do you think X is going to become? So if we inherit from the base class at a protected level, what protection level do you think X is going to become? Protected. Y is going to become protected. Z is going to become private, right? Everything has to be at least protected if you inherit at a protected level, right? So X got upgraded to protected level because protected is more stringent than private, more stringent than public, my bad. And so again, inside here, when we go to print out, we can still access X and Y because both X and Y are protected, right? And you have access to your parents' protected members. So no issues. Now, let's assume that we inherited at a private level. What do you think X is going to become? Private. And Y is going to become? And Z is going to become? Private. So if we do private inheritance, everybody's now going to become private. And so if we look inside, again, we can still access X and Y inside of ourselves because they've now been upgraded to private levels, right? But outside of ourselves, can anybody access X anymore? No, right? Because X we got is that we made it private, right? Could anybody access Y anymore? Well, they never could have accessed Y outside of ourselves or our child classes because Y was protected, right? But now if we inherit again, and again, I try to inherit publicly from private inheritance, and we try to print things, I can't print out any of the values directly because they're now all private in my parent, right? Again, here, second level inheritance.h, he's inheriting from private inheritance, right? So base class, right? X is public, Y is protected, Z is private. In private inheritance, we inherited at a private level, so X, Y, and Z all became private, which now means inside of our children cannot access any of them because they're private inside private inheritance. So sometimes like the private inheritance is used to make it so that you can't subclass anymore, or you can't inherit from that person anymore because you've made everything that was inside them private, which means none of their children could access them. So sometimes you do private inheritance to prevent further inheritance from you. But again, if we look back at private inheritance, wherever he was at, right, we still made these members public, right? So in second level inheritance.cpp, we can still call print private inheritance and have that work because it was a public member. And again, we as a child have access to all of our parents' public members. Any questions here about inheriting at different levels? Yeah. Hmm? Hmm? No, you couldn't say object : parent X anymore because it's private inside you, that whatever that member is. Hmm? I think kind of like what you're like getting at is something that's like over here, right? So we make our base class, public class, protected class, and our private class, right? And again, I can't, in the base class, I can't access Y or Z because, right, they're both, Y is protected and Z is public, or Z is private. Again, when I do the public inheritance, again, I can't access Y and Z because, again, both protected and private. Here inside protected class, I cannot access anything outside of it because X is protected now. And so your question is like, can I do something like dot base class : X? No. Right? Because it's now a protected member. Right? So no, you can't access X anymore. Even trying to be tricksy. It doesn't work. Are there any other questions? Yeah. So the question is, how are these runtimes enforced, or when are they enforced? Compile time or runtime? They are completely enforced compile time, and that the compiler is double checking that you're not trying to access those things. But if you do like funny things where you set like pointers to that area and then you cast the pointer and you move the pointer to the right spot for the private member and then you access it, yeah, you can totally get the value there. And the compiler can't catch that. So if you use enough indirection, you could do it, but you shouldn't be. Any other questions? Okay. So then, let's pop back over to our Pokemon code. Then our new branch will be AI branch. So we will pick up with this on Friday, I guess, because we only have a minute left. But think about how you might want to structure our Pokemon class so that we can support an AI. Where all our AIs for right now is going to do is to be kind of dumb. We're just going to randomly pick one of the moves to use. I'm not going to be smart about it at all.
Hey, I found a real quick error with your CMake list.